In the time it takes you to watch this video, a quantum computer could theoretically solve problems that would take your laptop millions of years. But here's the catch. We don't actually have those computers yet. Or do we? Today we're diving into the wild world of commercial quantum computing to find out just how close we are to a revolution that could change everything. I'm Alex Chen, and if you've been following tech news lately, you've probably seen headlines claiming quantum computers are about to revolutionize everything from drug discovery to breaking all internet security. But between the hype and the headlines, what's actually happening in quantum computing right now? And more importantly, when will it actually matter to you? Before we dive into the commercial side, let's quickly break down what makes quantum computers so special. Your regular computer processes information in bits. Think of them as coins that are either heads or tails, ones or zeros. Quantum computers use quantum bits or qubits, which can be heads, tails, or both at the same time thanks to quantum superposition. Imagine you're trying to solve a massive maze. A classical computer would try every path one by one until it finds the exit. A quantum computer could theoretically explore all paths simultaneously. That's the power we're talking about, but only for very specific types of problems. So where do we stand in 2025? The short answer is we're in the most exciting phase yet, but we're not quite there. Companies like IBM, Google, and others have built quantum computers with hundreds of qubits, but here's the thing, these machines are incredibly fragile. Most quantum computers need to be cooled to temperatures colder than outer space. We're talking about minus 273 degrees Celsius. They're housed in million-dollar facilities and require teams of PhD physicists just to keep them running. Not exactly something you'll find at your local Best Buy anytime soon. But the progress is real. Google recently announced they're aiming for commercial quantum applications within 5 years. IBM is pushing toward 1,000 qubit processors. And here's what's really interesting. Crossing that 1,000 qubit threshold isn't just about bigger numbers, it's about building fault-tolerant quantum computers, which are essential for real commercial applications. The quantum race has some familiar faces and some surprises. IBM is taking a steady, methodical approach with their roadmap clearly laid out. Google made waves with their quantum supremacy claims and bold 5-year timeline, but they're not alone. You've got Microsoft betting on a completely different approach called topological qubits. Amazon is building quantum computing as a cloud service. Even smaller companies like IonQ and Rigetti are making significant contributions. It's not just about who has the most qubits, it's about who can make them work reliably for real problems. Here's where it gets interesting for the average person. Quantum computers won't replace your laptop for watching YouTube or sending emails, but they could revolutionize several key areas that affect all of us. First, drug discovery. Pharmaceutical companies spend billions and decades developing new medications. Quantum computers could simulate molecular interactions in ways that are impossible today, potentially cutting drug development time from decades to years. Financial services are already experimenting with quantum algorithms for portfolio optimization and risk analysis. JP Morgan Chase, Goldman Sachs. They're all investing heavily because even small improvements in trading algorithms can mean millions in profits. And then there's the elephant in the room, cryptography. Most of our internet security relies on the fact that certain mathematical problems are nearly impossible for classical computers to solve quickly. Quantum computers could crack these codes like opening a lock with the right key. This is why cybersecurity experts are recommending that companies achieve quantum readiness by 2030. It's not science fiction, it's risk management. But before you start panicking about quantum hackers or, celebrating quantum drug discoveries, let's talk about the massive challenges that still exist. The biggest problem is something called quantum decoherence. Qubits are incredibly sensitive to any outside interference, like heat, vibration, or electromagnetic fields. Even just looking at them wrong can mess up their quantum state. Right now, quantum computers can only maintain their quantum properties for microseconds before errors start to creep in. Today's quantum computers have error rates around 1 in 1,000 operations. For comparison, your smartphone has error rates around 1 in 10 trillion operations. We need quantum error correction that can fix mistakes faster than they occur, and honestly, we're just not quite there yet. So, when will quantum computing actually matter? Well, the experts are pretty split on this one. Google says commercial applications could be just 5 years away. Some quantum researchers think we might see breakthrough applications in specific fields within 3 to 7 years. Others believe truly transformative quantum computing is still decades away. Here's my take. We're likely to see narrow, specialized quantum applications emerge in the late 2020s. Things like specific optimization problems or certain types of simulations. The quantum revolution everyone talks about? That's probably still 10 to 15 years out, but honestly, it's coming faster than most people realize. For most viewers, quantum computing won't directly touch your daily life for years. You won't be buying a quantum laptop or a quantum smartphone anytime soon. But the industry's quantum computing transforms will affect everyone. Think about better medications developed faster, more efficient logistics, which means cheaper goods, advanced materials that lead to better batteries, solar panels and electronics, and even financial services with better risk management. It's really less about quantum computers replacing classical computers and more about quantum computers solving problems that unlock innovations everywhere else. So how close is commercial quantum computing? Closer than skeptics think, but not as close as the hype suggests. We're in that fascinating phase where the technology is real, the investments are massive, and breakthroughs are happening regularly. But the truly game-changing applications are still on the horizon. The quantum revolution isn't coming overnight, but it is coming. And when it arrives, it might just change everything. If you found this deep dive into quantum computing helpful, hit that like button and subscribe for more tech explainers. What aspect of quantum computing interests you most? Drop a comment below. I read every single one. Advancements in technology are transforming our world. It is best when it brings people together. May the force be with you.